All right, so I didn't get any emails, and there doesn't appear to be anyone in the. Oh, I actually do have one concurrent viewer. So, didn't get any emails in advance. If you got any questions, feel free to ask them up in the chat. Otherwise, I'm just here to answer any questions you might have. So slide 20, the nomenclature of alkanes PowerPoint RNS. Let me download that. So we have 4-ethyl 4-methyl cyclooctane. So the R and the S for alkanes is ridiculously hard because you don't have heteroatoms. Where's my whiteboard? There you are. So this is very much one of those we kind of have to start. Well, let me draw it first. 2 shells. 2 more shells. Now we've got so I don't know if that's going to be dark enough for you to see. All right, well, I guess I can do it on the PowerPoint itself. So I'm going to switch it over to the screen so you can see what's going on here. All right, so how we assign the R here versus the S? Well, the challenge here is that we have to look at what this atom is bound to. So we look at the central atom, it's bound to 4 carbons, which doesn't do us any good. So we need to look at what's bound to those 4 carbons. So if we look at this carbon has 3 hydrogens bound to it. So we'd say C with 3 H's. Now if you look at this one, it's got a carbon bound to it and 2 hydrogens, and this carbon has about carbon bound to it, 2 hydrogens, carbon and 2 hydrogens. So off the bat, the first difference here is this one. Since the hydrogen is lowest priority, we would say this is the lowest priority group at number 4. Now we have to start working our way further and further out. So if we look at the next carbons out, so tell you what I'll do is I'll keep the initial carbons that are bound to this chiral center, we'll keep them as black, and so the next ones out, we'll change the color to, let's just make it blue. So we look further out, the methyl group has 3 hydrogens. This carbon here is attached to a carbon and 2 hydrogens. This carbon here is attached to a carbon and 2 hydrogens. So when we back this one out, we see that the first point of difference is this one. Since there's a hydrogen that's lower, this makes this one number 3. We move out even further. And we'll make these red just to make them stand out a little bit more. So this one's bound to 3 hydrogens. This one's bound to a carbon and 2 hydrogens. So this one makes this the highest, makes this one the lower priority. So this one ends up being number 2. And this one ends up being number 1. So you can see the challenge here is that we have to move successively further and further out. So I'm going to take these numbers, I'm going to move them close to the adjacent carbons. So we've got number 3 here, number 2, number 1. So now if we start looking at the rotation, and we go to 1, 2, 3, 4, we see that we do have this clockwise rotation because number 4 here is going to be in the very back, the lowest priority is in the back. And as we start going to successive lower priorities, we got 1, 2, 3, 4. This is a clockwise motion, so this makes this R4-ethyl 4-methyl octane. Now, this is kind of what you're going to see as we start moving further down. So saying like this 2s3r. Let me move this over. So let's focus on this carbon here. Again, this one's a methyl group, CHH. This is an ethyl group. Oh, actually, so yeah, with this one, hold on, let me copy over all my little notes. This one gets a little bit easier. So the methyl group is still, if we just only consider the carbons immediately around our chiral center. So I'm going to pull the other ones further out to make it a little bit easier to see. So this has a C, HH. This is a CHH. CHHH for the methyl group, and then for the carbon down here, it's actually CCH. So this one clearly has the highest priority. It's number 1. These two are still jockeying for second place. And this methyl group here is the lowest priority because it only contains hydrogens. Now, if we move out to the next atoms out, we end up getting a CHH and C with 3 H is the methyl group. So this ends up taking the high priority. So again, this is number 2. And this is number 3. So this is why we still have that 4R for the ethyl, with this being the 4th carbon. And the same line of reasoning would approach for this one. So let's say we want to look at this one here. Sorry. So we want to look at, I don't know why it says 3S4R. These are the incorrect numbers, but whatever. That's something to update on these slides. So if we look at this carbon here, we have a back hydrogen that's not drawn. So the hydrogen here is definitely going to be the lowest priority. If we look at this carbon, it's a carbon with 3 carbons bound to it, so CCC. This one has, sorry, let me get rid of the numbers for you. This is a carbon with 2 hydrogens. And this is a carbon with a carbon bound with 2 hydrogens. So off the bat, we quickly see number 4 hydrogens in the back. This carbon here is definitely number 1. It's got 3 carbons bound to it. These two we can't tell apart because they're both CHH, so they're a carbon bound to a carbon and 2 hydrogens. So if we move further out, for this one, this ends up being a methyl group. This is another methylene group, CH. So this would make this pathway here to the right the number 2 priority. And this chain down here, number 3. Now, since the hydrogen points back, we get 1, 2, 3. It looks like it should also be 3R. Looks like it should be a double R complex. So yeah, let me check on this one, but I think it's actually supposed to be R and R, and those numbers are definitely not correct on there. But definitely with this, other than the numbers not 0, 1, 2, 3, 4, numbers being correct. 2, 3, 2, yeah, numbers are correct on this one. They're not correct on this one. But yeah, that's how this is going to work. Is that you basically have to look at the more branch, the closer a. If you're looking for a quick way to do this, the quicker they terminate, if they're just a whole bunch of linear chains, that typically gives them the lower priority. The more quickly they branch, so let's say there's a branch on this carbon bottom and to the right versus a branch up here a few carbons away, the quicker they branch, the higher their priority is going to get. But there is a lot of painstaking work that goes into naming these with the R and the S. So hopefully that helped you. Other questions? Yeah, you're welcome. 24 and 25 on the same PowerPoint. So flip it over. So what happens when you have basically the same, you can draw the same length chain multiple ways. So in this case, we can draw, pentane is the longest continuous chain we can draw, but we can draw a pentane either in this C shape or we can draw a pentane in the blue as this continuous chain. The question is, which way do you draw it? Since there is no other way to draw a longer chain. And the answer is that we want to increase the number of branching. And that may sound odd to say, but by increasing the number of branches, we typically decrease the complexity of those actual branches. So in the case of picking these 5 carbons here on the left as the primary chain, we only have one branch, but it's an isopropyl branch. So the isopropyl branch is this kind of Y shape here. It's just considered a more complicated group. So something like sec butyl, tert butyl, all those are considered more complicated because they are branches that have their own branches. Whereas if we draw this linear chain of 5, we end up with a methyl and ethyl. Now, that does make our name longer, but it makes the actual branches themselves a lot easier to describe. Now, we could rename isopropyl, and this becomes a bit more apparent when you start getting away from trade names. The technical name for this would be 1-methyl ethyl. So it would be 3 parentheses 1-methyl ethyl pentane versus 3-ethyl 2-methyl pentane. So this is just the rule for naming alkanes. If we can draw the longest chain multiple ways and get different branching, we want to draw it in such a way that it minimizes the number of branches. Or I'm sorry, we want to draw it in such a way it maximizes the number of branches. And slide 26. This one, there is a typo. This should be 1,2,2 trimethylpropyl. The original version that got up there said 2,3,3. That's just a typo. So if that's your question, it should be 1,2,2, not 2,3,3, as which was originally written up there. And this one by design can't be written. This dodecane was intentionally picked. That's a huge change. There's no other way to draw it, at least in terms of this example. So it says, can you name the molecule? you happen to have a slide number? Just because there are like 76 slides in this presentation. It's 25. That should get me close. Okay, so my slide is 23. So in terms of naming the following compound, you want to look, oh, so this is actually the one that follows it. So in this case, it does work it out for you. It's 3-ethyl-2-methylpentane. But this is actually a worked example in successive parts. Not that one. Do you have the title of the slide? Oh, okay. I think I know what's going on. All right. So you're working with, okay, so this is my copy of the notes, and then there's the ones that were shared development. Okay. You're working with the shared files. Nope, that's not it. Come on. Okay, this one. All right. So in terms of naming these, we can go through one by one. So when it comes to A, we want to figure out the longest chain. So 2, 4, 6, 8, 10. I see decane. 2, 4, 6, 8, 9. So if I draw just so I've got it there. The longest chain here is the decane. So we're going to start naming from right to left. So the longest chain here is decane, and the decane is going to be the branch that runs 1, 2, 3, 4, 5, 6, 7, 8, 10. So question C, 2,4-trimethylheptane. So to draw that one, I'm loading up some drawing software. Give me just a minute. So we'll start right to left. We have heptane. So we have 1, 2, 3, 4, come on, 5, 6, 7. Make this a bit bigger for you. So that's our heptane. 1, 2, 3, 4, 5, 6, 7. And then we know that there's 3 methyl groups. There's 1 on the second carbon and 2 on the fourth. So that's your 2,4-trimethylheptane. And then the next one, 4-isopropyl-3-methylheptane. It's still heptane, hex, hept, yep, 7. So you got 4-isopropyl. So 1, 2, 3, 4, and then the isopropyl is 2-methyl ethyl. and then you've got 3-methyl. So that's the answer for D, and you can just back the video up to see the answer for C. Apparently the example changed between slides because that's heptane and that's nonane. Yeah, you're welcome. Other questions? Slide 35. What is the correct ion name for 2-ethylpentane? So let's draw it out. Where are you? There you are. So if we just draw out what they have written, which is 2-ethylpentane. So 1, 2, 3, 4, 5. It's 2, not 3. So as they have it drawn, this is our ethyl branch. Here's our pentane, but clearly it's not the longest branch. Probably have to zoom that in for you. So it's clearly not the longest branch. So if we redraw this, we get 1, 2, 3, 4, 5, 6 carbons is the longest branch. So that'll be a hexane. And we have one methyl group, so if we put it on the 1, 2, 3 position, this will give us 3 methylhexane. So another way we could do this is we could draw out the structures that are there and see how they compare. So it's definitely not N-heptane because it has a branch. So let's try 2-methylpentane. So if we draw pentane, 2, 3, 4, 5. And we erase that and we do 2-methyl, we get that structure. So that's 2-methylpentane. They're clearly not the same thing. If we do 2-methylhexane, it's kind of the same thing, is that there's our hexane chain, 1, 2, 3, 4, 5, 6. There's a methyl, they're not the same thing. So if we do 3-methylhexane, you may sit back and say, well, these don't look like the same, but let's say I rotate that. It's going to be a lot easier if I just rotate it there. Oh, that's why we're missing one. There's your hexane. There's your hexane. If I just take this and rotate it, and then just rotate that bond around, they end up looking like the exact same molecule. So yeah, there's two ways to do it. One is just draw what 2-ethylpentane looks like, and then go back, tweeze out the correct longest chain, and you'll get 3-methylhexane, or draw each of these out and compare them to the 2-ethylheptane. Now this is the power of the IUPAC system. Even if you completely name it wrong, so this 2-ethylpentane here is entirely incorrect, you can still recreate the correct structure. Yeah, you're welcome. showed on slide 21. Thank goodness there's a lot of slides. So how many primary carbons are in the molecule shown on slide 21? So we're going to slide 21. So in terms of primary, meaning ones that just contain a carbon bound to another carbon, there's 1, 2, 3, 4 primary carbons. The CH3, 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 and CH3. We've got 2 secondaries. We've got the secondary here, the secondary here, and 2 tertiaries, one here, and we don't have any quaternaries with these. Okay, so I'm guessing you mean slide 32. How many primary carbons are in the molecule shown below? Again, primaries are going to be the ones where it's just the end of a line. So 1, 2, 3, 4. Asking you to name the primary carbons. There we go. Okay, so on slide 33, slide 31. And the 3-methyl-2-ethylheptane carbon number 3 marked star is classified as. So primary has one carbon bond, one carbon attached to our central carbon. Secondary has 2, tertiary has 3, and quaternary has 4. So in this case, we count 1, 2, 3 carbons coming off of it, so this would make it a tertiary carbon. And then your CH3, 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 those are all primary. Anything that says CH2, that's going to be secondary. Anything that says CH is tertiary. Anything that just says carbon, that's going to be your quaternary. You're welcome. Should stop thumbing through the notes while you're watching a live stream. right, so come up on the end of the live stream. Thanks for the questions today. And again, if you ever have questions, feel free to shut the live stream. Feel free to ask in advance. Even if you are on the class and you just happen to find this live stream, feel free to ask questions. That's kind of what I'm here for. And I will see some of you in about an hour and the rest of you hopefully next week.